Welcome, everyone. How's it going? Hopefully, we've got a couple of people that have joined the stream. Let us know if you have in the comments and let us know where you're from. We've had a exciting last couple of weeks, so we accidentally missed last week's episode, so apologies, everyone. I had internet issues at my house, and Paul was out, and it was only Aaron, but he doesn't have access to run StreamYard. So, so it was perfect storm. And then this week we've been geeking out about a number of things, including Python in the browser, which could be cool for data science folks that are interested in kind of having like light notebooks that run on people's machines without them needing to install Python itself. So I've kind of been geeking out about that feature in particular. But this week we are going to focus, at least today, on AWS Device Farm. So AWS Device Farm is a pretty cool service that allows us to do testing across multiple devices. I remember back in the day when I was an app developer, I used to have like 20 phones charging on my desk, and all of them had to constantly be charged. I'd run out of USB ports. I would have to manually install the new versions of the app on each of the phones, test to make sure the 20 variations of map libraries for Android, for example, all ran okay across the devices that were in the Australian market. And then I'd have to fix things up if I saw any peculiarities in phones. Screen size was another big problem that we had testing across devices. So Device Farm takes all of that burden away. You as a developer can produce an APK file for Android. So you build your app, produce that APK. IPA for iOS is exactly the same. And hey, Tori, welcome back. And what you do is you basically load that file that you've produced into Device Farm. You load in some of the tests that you want to run, and you hit go, and you can run your application across hundreds of devices, and then you can get all the outputs on where it failed, what might not be clickable, what might not have worked as expected. So we're going to play around with all of that today. I did want to kind of open up beforehand to Paul and Aaron. Any exciting news on the AWS front that you saw in announcements this week?
Well, like you said, it's been 2 weeks, but I think that there's two specific announcements that I thought were really relevant. I think one is bigger than the other. There'll be one is a really interesting one that a lot of people should probably spend some time looking at, especially if they're building something on a relational database. And that is that Aurora Serverless V2 went GA. So I think that that's pretty huge. Look, I have customers using Aurora Serverless V1. I've used that in the past as well, and it works okay. Like it works okay as a service, but it wasn't as responsive as we would kind of expect for a serverless. Anything in the serverless land, we kind of expect scale to happen and change to happen immediately. I know, like in serverless V1, if you let it cool down and go completely off, it'd take, I don't know, I forgot, but 5 to 10, 15 seconds, maybe a little bit longer to start itself back up again. And scaling was a little bit slow. So it was a little bit clunky, which, I guess is why the team came out with Aurora Serverless V2. So that caused a lot of excitement on a number of teams. But moving into GA is probably came sooner than I expected. So internally, I was sort of told that it might be a little later than it did come out. So I think that that's really great news and really exciting. And the other one was MSK serverless is also, so our managed Kafka servers has also gone GA. Look, there's still so many people looking for a solution that hooks into a lot of their existing platforms, isn't specific to some of the AWS services, and provides, I guess, a little bit of, it's a little more flexible to what you're doing in your programming model. Like Kafka allows for compression on the fly, allows for large message sizes, allows for Kafka database where you can run queries on the fly across data streams, query across different data streams and extract different data. There's a whole bunch of features that Kafka provides that our Event Bridge, SQS, SNS don't quite provide as well. I mean, it's not going to scale, and it's not going to provide the native integration that our other messaging platforms provide. But it's still something that so many customers are using and interested in. But building something like on top of something like Kafka comes at a, that problem where you have to scale it. So either you install it, manage yourself, or use our managed service. Then what happens when you have like a big on sale or some sort of scaling event, it becomes difficult to scale those things up and down, requires a little bit of downtime. So I think like, MSK Serverless is a really great thing that's come out in GA. So yeah, those two things specifically I thought were really interesting and worth mentioning on the show. And while Aaron might have his spiel, I'll find those links and paste them in as well.
Yeah, cool. For me, this is not a new feature. More, it's just new, launched into Asia Pacific. So both Asia Pacific, Singapore and Sydney was the RDS multi-AZ deployment options. So this, for a lot of the people or a lot of customers that I work with, obviously they rely on data being in region. So Sydney here in Australia, and looking for more, I guess, less latency for read options when they're doing their RDS instances. So the capability of being able to have your primary RDS instance and then 2 readable standbys in different AZs. For me, this is probably a really big thing for enterprise level, I guess, data resiliency. It basically speeds up the commit capability, as well as I think it's reduced the failover time from your read standby by down to about 35 seconds. So in the event of your primary failure, the failover will go to, I think, 35 seconds. I'll need to go back to the announcement and have a read again just to make sure that 35 seconds is correct. But I'm pretty sure that's right. So like the failover now to the read standby, that's a big one. So a lot of the solutions that I work on with customers are around resiliency, high availability. Having these options for RDS is a really big deal in this region. It's been available in other regions for a while, but now Asia Pacific's caught up.
Excellent. I'm surprised. Like maybe it's because we've had a 2-week gap, but I'm surprised neither of you mentioned Aurora Serverless v2.
I just did.
Oh, you did? I missed it, maybe. I saw IoT. I take it back then. I saw IoT TwinMaker went GA as well. And then last but not least, Amplify Studios Figma to React got announced as being generally available during San Francisco Summit.
Yeah.
Yeah, awesome.
Yeah, so
I think that makes a really good segue, Matt, with Summit. So, usually we do a lot of feature and product announcements around reInvent, but this year we're seeing some additional feature announcements coming out at Summit. Just to remind everybody in the audience that that ANZ is having its Summit event in only 2 weeks. Matt and Aaron and myself will be there in person, which will be really great. We'll be doing a special Devs in the Shed episode, like up late with at Summit with Devs in the Shed. But also we'll be streaming at our usual time. While we're there, we'll be taking a bit of footage and showing what's happening on the floor. So people that are interested in seeing what's happening in the in-person event can see a little bit of what happens at this event. And of course, this year, it's still a little smaller than it typically is, but it's really great to have something that's, something that is a little bit in person collaboration that is happening. But for everybody else, and, there's probably still a lot of us that aren't really up to travel at the moment or aren't quite ready for it, and are waiting for like a bigger event. Summit is completely online as well. So it's completely free, and all of those sessions will be available online, including some like really great keynotes. So I've seen the lineup for the keynotes, so they look really great. A whole bunch of team members of mine are have already prepared and worked through their presentations they're presenting. So there's a lot of developer focused topics there, as well as all the other specific ones. But there's some really good developer focused topics, and I think that if you haven't attended Summit, or even if you're just to want to see a couple of those sessions, I highly recommend you register for that. As I said, it's it's completely free. Typically they have Matt, do you want to post that the registration form? Oh, you did.
Yeah, I have. Yep.
Typically through there, they usually have some prizes and competitions. So, you might have a chance there to win some swag. So if you want some AWS swag, which is always really popular, go ahead and register for that as well. We might have some special Devs in the Shed swag to give away at the time. So yeah, really looking forward to that. And we've got a special interactive event planned So our show should be really fun. But Tori, no, there isn't. But we'll, like, next week when we do Devs in the Shed, we'll let everybody know the exact scheduling of when our time will be, so that people can go ahead and make sure they mark that in their calendar, and so they know exactly when it is. Is it there?
So it's actually in the up late sessions.
Yep.
So you can see Devs in the Sheds mentioned in the up late sessions. They're still working on like building out some of the sections of the agenda. So if you refresh the page over the next week, you should see some new stuff pop in. The one call out actually is so we, other than missing due to no internet last week, we'll be around same time next week for everyone. So we always consistently kind of go live 12 p.m. AEST time every Wednesday. For Summit, they are actually going to be live streaming the whole of Summit. So what that actually does mean is that we won't have in 2 weeks' time Devs in the Shed at the normal time. But the consolation prize, which is probably better, is that we'll be on the up late part of the stream. So we will make sure that
Summit.
everyone's aware. Yeah, at Summit. So we'll make sure everyone is aware of that time, because we just won't be in 2 weeks able to grab that like usual slot, unfortunately. So I'm like super pumped for Summit. I think it's going to be absolutely awesome. You saw the developer track beforehand, day one. I'm looking forward to Derek Bingham's talk on Amplify. Arden, who's a really smart microservices and builder experience guy, he's got a talk later in that day, I think, on microservices, monoliths to microservices, and leveraging like APIs within your apps. Like that sounds interesting, so I'm probably going to watch that one. And then you can see on day 2 as well, like there's a lot of fantastic talks there as well. But don't just look at the developer track. I'm always going to be biased. I'm always going to be watching the majority of those sessions. Check out like all the other areas. The enthusiast stuff's going to have some IoT. I saw there's Deep Racer. There's going to be a lot on sustainability. Architect is always good as well, because that helps to work out how you want to shape your workload or your application as well. But definitely check out Summit. So anyways, enough about Summit, I reckon. Today, let's start on AWS Device Farm. So has anyone used Device Farm in the audience before? I'm guessing it might be a quiet no. I know it's like one of those services that we have a lot of people use in businesses, but I don't know how many people have built mobile apps in the chat.
So I've used it with my customers, and for the exact reason that you've said, Matt, that making sure that your app works across a variety of different devices, screen sizes, and specifically, like if I have a specific device that I want to tune that to, I like one of the companies I worked at, like a couple of jobs ago, we had devices all over the desk, right? So a service like this didn't exist. It was difficult, time consuming, like non-automatable, and expensive to go ahead and like buy and have all those devices. And, they get dropped, they get misplaced, they get lost. Other teams want to borrow them. So it's always a hassle having like physical devices.
Yeah, that's right. And the other thing that's not too well known is that Device Farm now supports browser testing as well. So you can use it for testing websites. A little bit different to unit tests. So most developers are familiar with writing unit tests. The reason why you'd want to write additional tests that run across devices is usually for those UI concerns that Paul mentioned beforehand. And so this is where and inconsistencies between hardware on devices. Yeah, go Aaron.
That's all I was going to call out. Was before, when you were saying you used to have your big suite of devices, and I came from an environment where we would rely mostly on the emulator. So we would be using Android Studio. We'd have many versions of an emulator running so that we could test it. But what we found is when we did get onto the hardware, it didn't work the same. Even for the same specification emulator, we'd still have issues on the actual device. So this definitely helps to solve that by running it on physical hardware.
Yeah, that's exactly it. So I'll share my screen again, and what I want to do is I kind of want to walk you through a app that we have, so you can see it all in action. Should pop up for everyone now. So I'm just in the AWS console. What I will do is I will search for Device Farm. Now, if you want to try out the service, there are free hours that you can use without being charged for Device Farm. I think it's 1,000 all up, if I remember correctly, Aaron. Don't quote me on that, but you can see in my particular account, I've got 572 hours of free time left to kind of experiment with Device Farm. And then pricing wise as well, if you run it longer term in organizations, you basically can pay all you can eat for $250 per concurrent device that you run in Device Farm. Or you pay something like, I think it was like a few cents per minute. Let me have a look for everyone just so we know. Where are we? 17 cents, yeah. So first 1,000 minutes is free. 17 cents after you've gone past your 1,000 minutes. And so it's a relatively cheap service compared to buying, like as we did, like $20,000 phones back in the day to have sitting at my desk.
This I found the middle option the best, the unlimited editing. Oh, sorry,
Yep.
unlimited testing.
Yep.
Especially for enterprise who are actually doing a lot of mobile development. $250 a month is nothing when in the scheme of if you're pumping out apps or if you're pumping out solutions for mobile. The amount of testing that you can do for $250 a month far exceeds that of if you're doing as the pay as you go.
Yep.
Yep.
Yeah, and then if you want your own devices, like this is a shared pool of devices, so you've got a large range to select from. But if you want to have like your own particular iOS device or whatever, you can have AWS support team and the Device Farm team effectively deploy that device for you. So they'll go and source it on the market. They'll put it within the AWS clouds. They'll make it available to you, and that's usually $200 a month. And you can go 6 months or longer for that price. The price does vary. So if you order like a $5,000 top of the line iPhone, it's going to be a bit more than that. But the starting cost is like $200 a month, and that basically buys you a nice Faraday cage and harness and EC2 instance effectively, and the device itself, of course, if I forgot to mention. And you can have all of that available in your account, so you can do unlimited testing on that particular device without having to pay the public device prices.
Matt, it's probably a good call out that this is like these are actual devices that your application is running on. So these are not virtual devices. So we all know that if you've been building like Android apps or like iOS app, you get the virtual devices. They're good to a point, but it's not quite the same as the real device. So these are real devices that are hooked up. So your app is deployed on a real device. So that's why you say if you needed a device that we don't currently support, like out of the box, you can request that specific device, and the Amazon team will purchase that, and they will place that in the cage of that actual device, and nobody else will use that other than you.
Yeah, that's right. And there are a couple of limitations as well when you do use Device Farm, but they all make sense because it's actual real hardware. And the first is like if you want to use your camera for part of your application and you want to do some testing around your camera, you've got to use a mocking library for that. Because these devices are just going to see nothing, right? Because they're in their own little private encapsulated device holding them. So the camera is not necessarily going to work. And the other thing is these are, as I mentioned, harnessed into AWS and EC2. So that basically means that we emulate network connectivity, GPS coordinates, and those types of things. So you can test around shaky 3G connectivity. You can test around strong 4G connectivity. We've got different profiles for all of that. And then you can put in like GPS coordinates that you want to simulate. But you also have to think about that when you use Device Farm. So you can see a full list of the public devices in Device Farm. So you can see we've got a bunch of iPads running different versions. If we keep going along, you'll see a whole bunch of Android devices. We have tens to hundreds of each of these devices. So there's always going to be something available to you. Let's go ahead and actually have a play with it. So what I'm going to do is I'm going to start a new project. And I'm going to call my project app testing dev shed. let's go with that. So this project is where we're going to have a series of runs for our mobile applications that we might be building. You can actually do everything through CLI or CI/CD, so you don't actually need to run any of the tests in the AWS console. And the reason why I mention that is, like, most people that use Device Farm probably don't use the UI. It's part of their CI/CD pipeline. It produces a build, it does the testing, then it returns the results, and then they might decide to push to the App Store or whatever it is next. So a lot of Device Farm does sit within that. We've got native Jenkins support for it. We've got examples of other CI/CD frameworks. We've got a few other plugins for different applications too. But within your project, what you might want to do is you might want to test a particular version of your app. So you create a new run. You would choose your mobile app. You can see web apps on the side there. We'll talk about that a little later as well. So you can do browser testing, as I mentioned before. I would then go in and choose a APK file for Android. This is just one of the demo apps that we've got. This will slowly upload on our internet, so we'll just give it a few minutes. I think it's like 50 megs or something. I can't remember the exact app size.
So as a point out there, there's a maximum app size that you can actually upload as well, and that's I believe that's 4 gig. Yeah, 4 gigabytes for a maximum app. So if you're building an app, first of all, if you're building an app more than 4 gig for a device, it's pretty epic. Because you can get a lot into like a game. Like I'm not saying it doesn't
but you
happen.
wouldn't be doing that anyway, though, right? Like, because the App Store has restrictions on size.
Exactly.
And so usually, if you're doing a game, you actually like have a shell,
custom installer.
And then a custom installer that launches within the shell that will pull the rest of your game contents down. So you might have the source code in the app, but then all the art assets, etc., will come down the first time you open. And that's why you sit there for like 5 minutes waiting after you've downloaded the game, doing the download. Yep.
So for business applications though, like 4 gigabytes, I've not seen like business workflow application type style apps exceed 1 gigabyte. So you're getting pretty big if you're getting over 1 gig, but just keep in mind that you've got a maximum of 4 gigabytes that you can use for testing or uploading into Device Farm.
Yeah, and usually, like I'd say, if I ever did see a 4 gig app, I'd probably suspect
I'd be
that they're
questioning
embedding,
it.
Yeah, that they're embedding like 4K videos in the in the app rather than
pretty massive.
the cloud. Yeah,
that's right. There are always ways to make it more efficient. Downsize it.
Yeah. Cool. So we'll give the run a name. So we'll just call this run 1, for example. You can see that it picked up like a whole bunch of metadata around my application as well. So it picked up like the name of the app. So you can see it's reference app.android, blah, blah, blah. You can see the minimum SDK version that this app supports, the target SDK version, so it's 29. You can see that it's defined a series of screen sizes that it's compatible with. And then you can see the versioning from the code, etc. So that's pretty cool. I can make sure that I've pulled the exact right version of my application down. Now, this is where the fun begins. So there are 2 tests that I find rather fun to run by default. So let's say you've never done any UI testing in your application. You haven't kind of built any proper tests yet, but you do want to like test your app across multiple devices. Fuzz mode is effectively going to randomly tap sections of your app and then try to break it over a time period. Explorer mode is going to try and find the deepest sub view within your application. So it'll keep going with the navigation to get to a deep view. So these are modes where you don't actually need to provide your own tests to run on top. So they're particularly fun. We might do one of these later. But for
they're
now,
probably good ones to like determine whether specific tapping just crashes your app, right? Like we've all had apps where you can just tap lots of times, go into certain areas, pressing certain buttons, and the app will just crash. And exploratory testing by a human like that is difficult because you typically, it's not exactly the same every time, right? So, and it's costly, right? You're tapping all over the place. It takes a lot of time. So, those are some good ones, especially even if you're just getting going.
The fuzz one always reminds me of. I know this is a bit of a sideline, but fuzz always reminds me of. I always think of like Grover or Elmo sitting in the Faraday cage going on a device. It's a fuzzy monster.
I always think of a British movie involving police. Whenever
The fuzz, yeah,
the fuzz. Yeah. So basically, those two modes are quite good to get started. But if you're starting to build your own tests, like you might have a login screen, like this example that I've got, and you want to test to make sure that the incorrect password box comes up when an incorrect password's entered, and a correct password box comes up, and the user is logged in. If they enter the right password. So you basically define your tests, and I'll actually, if we have time at the end, I'll show you Appium so we can have a look together at creating these tests. But this zip file is basically full of effectively two things, right? Like it's got the metadata around what's required for the Appium server to run. So it's got like a YAML file that includes that. And then the other thing is it's got each of the different tests that you might have in particular as well. So if we scroll down, this zip file that I've uploaded with my tests, you can see that it's picked up that there is this YAML file that said we want to install 14.19.1 of Appium. You could set up other things in here as well. Like if your app's internal only, you could potentially set up a proxy to allow you to test certain things in your network for this device, even though this device is out in the wild. So similar to configuring a proxy on the phone. Private devices, so rather than the public ones, private devices are a little more configurable. Like you can actually log into the App Store. You can set up a proxy in the app in the device's settings. Or a VPN tunnel. The other thing with private devices as well is they can give you, they can actually have a VPC endpoint issued, and you can use that to then route through to your internal app servers that might be doing something in particular for your device, such as like logging into user or pulling data. So that's really good if you haven't exposed anything publicly yet. You're kind of in testing mode internally.
Before you move on to the next set, Matt, Milkman asked this question, like, are these being run in containers? And I assume what he meant is so for anybody that hasn't done like automation testing, you have like some server or something somewhere where these tests are executed against that, that remote device. And in this case, that remote device is like that phone, whatever it is, or tablet. So I guess like what Milkman was asking was, when you upload these tests and where they run, are they run in a container? Do we know anything about it, or is that completely abstracted away from us?
So a lot of it's abstracted away from us, but the APK or IPA file is usually stored along with the tests on S3, so you can reuse it across multiple tests. These are real physical. Yeah, go ahead, Aaron.
The APK is deleted after 30 days. So they don't hold on to the app for more than 30 days. So yes, it's there for use across multiple devices, but after 30 days, if you're not still using it, it's gone.
Yep. And then I guess rather than run in containers, like these are real physical devices that we actually are running that sit within Faraday cages. And the tests are executed from an EC2 instance that can talk to these devices, right? So when we start these tests, basically like an EC2 instance, has a virtual connection to a device, like a virtual USB, and it can basically like inject the install file, inject the unit tests, send commands for the phone to start up and etc. So you can see all of that actually in action as this goes along.
It's the equivalent of plugging your phone into your desktop with the USB and having it in developer mode so that you can run tests remotely.
Yeah, exactly. You can get video recordings of what happens as well. So if you're doing this remotely and something breaks, you might want to send a video to a developer alongside the logs that just shows where it broke. I actually had like an issue with React Native this week. So I had a sub view in an app that was above the the notch on the iPhone. And so what that meant was some users couldn't actually reach my my close button for a particular view, and that was all because I was dumb and I forgot to do a safe area for that particular screen. But that was actually caught by Device Farm. It picked up that I hadn't equated for the notch for that particular device, whereas all my tests passed for all my other apps. So that's just an example of one of the things that I caught, display sizes. What you can do next is you can create a pool of devices. So with Device Farm, you can have the top devices that people test against as the ones that you select as well. You can search for devices that you might want to run tests on, or you could create a device pool if you've got particular devices that you want to test against. So you might go, I want to make sure that the Samsung range is going to work because I've, for whatever reason, my app's been problematic with them in the past. And then I could select like all the Samsung devices if I wanted within my app pool. I'll stick to the top devices now. You could pick by like an operating system version as well, a device type, and all these other things. Now, I don't know if the concurrency's changed recently. I think it might have, but everything runs asynchronously across multiple devices. So that basically means that you can have your app run across 5 devices at once, and it will pick the most highly available devices to run the tests across first. But if I have 20 devices picked here, it will start across the top 5 most highly available, and when one device finishes a test, it then launches the next device to then go through and run testing on as well. So that's kind of important to know about. But you'll get your results for the first 5 devices within a few minutes of the test running, depending how complicated your tests are.
So Matt, that's probably an interesting comment that people might be thinking about, is that because these are physical devices, if a lot of people picked a specific device at a point in time, we may run out of available devices at that point in time. So then there'd be a queuing mechanism to have access to that. So these are like devices that are shared amongst other people that after each run are like wiped and put in a reset state, a completely reset state. Whereas if you had the private devices, you would always have access to that device. So yeah, there's a sort of a difference between that as well.
Yeah, that's right. And I think that also answers Shady Milkman's question.
Oh, yeah.
A great name. So after you run a test on one of these phones, is it easy to reset the phone in order to prep it for the next test? That's exactly what happens, right? Like with the shared devices, each time you've run a series of tests across that device, the device is wiped before it's returned into the public.
So just it's order of correction there. It's not wiped. It does go through an uninstall. So they uninstall your app and they uninstall any changes. However, it's not a fresh install of the iOS, like of the
it's not a re-imaging
of OS.
Of like,
it's not re-imaged, no. So it's just uninstalled anything that you've done. So if you're just to this point, right? If you're actually working in system settings and working in things outside of your app specifically, some of those changes will remain because they're outside the scope of the uninstall. But to that point also, if the system cannot verify that it's been uninstalled, the device actually gets removed from being able to use until it can be like fixed, basically. So it's not a wipe. It is just an uninstall.
So if you change,
but it includes user data as well.
Another customer,
it does.
So me changing something in system settings is not going to impact somebody else. The next person's going to use that device.
Yep.
And I might just did Paul? Did you share that link that Aaron had? I don't see it.
I'll do that.
I'll just post it in now. I was just like looking through the history. So this is the available devices on Device Farm. And so kind of like talking to that extra point, like I could have some extra things that are installed as part of this as well on top of my tests and top of my application. I have seen, even though apps are sandboxed on iOS, I have seen instances on Android where having certain apps installed alongside other apps have caused problems with the app running.
So
and then I've also seen times where you might need like a secondary app to perform authentication and pass something back to your first app as well. So that's quite common in enterprise.
That that's actually kind of common. One of the common questions that I get is like, what are the apps? Like, are other apps installed? So like, yes, the answer is any manufacturer apps. So like when devices get released by the manufacturer, all of the pre-installed apps are already there. And then any carrier apps. So if specific carrier are deploying the phones, then they have specific apps. They're installed on the device as well. But also to the point around being in a sandbox, every device actually does have. It's not on cell, but it does have a Wi-Fi connection, so you can actually get access to the internet from the device. So if your app does depend on a web view to another server, or if you're connecting or communicating with other things out in the world, then it does have that internet connectivity.
Yeah. Yep. And what was the other thing that I was going to talk on that? We're actually configuring these things at the moment as well, right? So you might not be able to use Bluetooth, but like if your phone looks for, if your application looks for Bluetooth being enabled, you can enable it there. You can mock a GPS location here as well. There was something like you prompted me. I've forgotten. If I remember, I'll come back to it.
The carrier profiles?
No, it wasn't the carrier profiles, but you can simulate different network connectivity types as well, right?
Yep.
So if you've got users that seem to be having problems using your application when you've got like a 3G lossy connection, so 3G, but it was very, very poor and it keeps dropping, you can emulate that using the network
TLE
profiles.
Yeah,
Wi-Fi, good connections, like a series of these things. Like that's all here. You can create your own profile, so you can kind of like customize everything down to the nearest detail of like if you've had network tests in that area and you know that like this is generally like the pattern that you see in that area and you want to test against that pattern, you can define that there. I think that's pretty much it in terms of like setting up the device state. Now, the final screen, where we can just review all the settings that we've got, does have the execution timeout as well, which is important to note. So, by default, if you run Device Farm and it takes longer than 150 minutes, it's going to stop your run and clean everything up and return it back to the pool. And the reason why we've implemented this this limitation here is a lot of customers, if the application's broken and becomes into a stuck state where like it's frozen, you can't get out of it, like it can't run the next test, it's trying, it's failing, whatever it is. Returning it after 150 minutes means that you won't get a bill for 1,000 hours if it's just stuck in a stuck state forever. So we kind of have that limit, but we also see customers that are quite frugal that go, hey, we know that our test should take no longer than 5 minutes on each device. And we don't want to pay for more than 5 minutes. So you can kind of define that here, or you go like, it shouldn't take longer than 15 minutes to run this and give it a bit of breathing space. But execution timeout is going to save you money if something happens with your application and it just completely freezes up. So what I am going to do is I'm going to show everyone what the run looks like from the console. So I'll go into the run itself. So you can see run 1, it's starting up. You can see the devices that it's selected. I can see that they're all impending at the moment. Now what's going to happen is each of these devices are going to be secured from the Device Farm network. And they switch to a running state when they've been appropriated for your use. I don't know the correct word for that. It didn't come to me fast enough, but you can actually watch what's happening in real time with these devices. So as this run's happening, you can see some of the logs. You can see a video as well of what's playing out on the devices as it happens as well. So if you're really inclined to, you could sit here and watch each of the runs go through and see things in real time. Now, my recommendation is always just do this from CI/CD, right? And just get the logs at the very end, but it's cool visually. So I'm going to let this go through and do a few runs. But what I might do is I might go back to my project and I might go, okay, well, I'm doing automated tests, but this user has given me this really poor App Store review. said my app's terrible and crashes at this particular moment in time. So what I can do is I can get the details from that person of that device, and I can actually test in particular if my cases don't cover it. So I can go, okay, so they said that they had a, let's say, like a Google Pixel 4. Actually, let's see if I can find a particular. I might go for a Google Pixel 5, actually. Yeah. They've got a Google Pixel 5, and I can actually secure this from the Device Farm network as well. And I can load my application onto it, and I can actually see the screen, and I can perform those steps that the user mentioned causes an app crash. So not only can we do those automated runs, we can actually like get hands-on with a particular device for this style of testing. So this might take a few minutes.
While that's loading, I just had a thought sort of back to Shady Milkman's query around the instance or the host that the device is running from. Just a couple of things to mention, both the device and for the host. If you're using like client service type software, like Appium in this case, you can actually get access to the host shell. So you can execute limited shell commands from the host to support your testing, as well as support any client-server communication. And then the other one that often comes up is, especially in Android, does it have the Google Store installed on it? So there's no default Google account, but every device that supports it has the Google Store. So if you're interacting with Google Store for your app, like purchasing, that sort of stuff, you can still test all that with the Google Store on the device.
Yep. Yeah, that's a good call out. Well, it's taking me a while to get a Pixel 5. So this sometimes happens where it takes a little while to get a device started.
I was going to go back while we're doing this. Like, you know, when you've built your app, one of the hardest things to do as a developer is figure out what somebody did to cause that problem to happen. And so whilst yes, I agree, like it should be done through your CI/CD pipeline, the recording and the ability to like watch it to see what's happening is like incredibly valuable, right? Like you'll be able to determine, oh, at that point where they click there, that's when it crashed with exactly this thing happening. And so like, you know, when you replay that back to I guess like a more real, a manual testing solution, sometimes even going back and asking the tester, what was it that you did that made that happen? Like, you know, I'm sure both of you guys have been in it, and I'm sure audience people have been in it, and it's like, I don't know what I did. I need to go back and try to reproduce that crash, and that can be really difficult. So, you know, having that recording or being able to watch that happen when you're using something like, you know, the automatic exploratory testing can be like exceptionally valuable.
Yeah, absolutely.
And I'd say like in terms of that CI/CD case that you talked about, it's like this might run successfully across 50 devices, right? But then you've got the one. And so in CI/CD, you can have that like video and logs and screenshots and all that data shared for you for that one device, and then worry about it then. But then if it's been successful, you just want to see a tick in the box, like, yep.
Exactly. Yeah, you don't want to know that things are failing, but when it does fail, you want some sort of process that says, hey, you got a message in Slack, something failed. You want to be able to directly go to that video, watch that video and say, right, at this point here on this specific device, when the user clicks on this area, it crashes the app. And, you know, we all know like retracing those steps is much harder than actually fixing the bug most of the time.
Yeah. Well, that's the good thing about the results, though, too, that it presents both in a high level and a detailed per device level. So you can look at the videos, the logs, you know, look at everything that's going on when the actual specific device had an error.
Yep. Yeah, and I think everyone in IT knows this experience, right? Like where someone says that the app does X, and you're like, you can't replicate it on your side. And so having their device, the exact same model running the exact same version is very handy. But yeah, I'm just like flashing back to all those times where I've used TeamViewer or other platforms that are like it, where I've had to,
if
like,
you can't reproduce it, it didn't happen, right?
That's
yeah,
right.
yeah. You know, like my grandparents, right? Oh, the file menu is not there in Office. And I'm like,
Or
what do
there's
you mean the
the
file menu's not there in Office? It's got to be there. And then you kind of like, you get to actually like follow them through and go, oh,
coming
yeah.
coming from the developer side, it's always the opposite as well. Not the I can't reproduce it as the IT, but it worked on my machine, so it'll work on yours.
Yep.
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 Yeah.
Worked on my device.
Yep. I remember what I was going to say before, Aaron.
What?
So, like one of the other things is like we didn't really talk about emulators versus simulators versus
Oh, yeah.
actual devices, right? So like on iOS, it's simulating a environment for your application. So you can change different device types with an Xcode within the simulator, but you never get access to push notifications. So if you actually want to see push notifications, you have to have a physical device with you. The emulator, it gives you a lot more flexibility, but it's not the same as running it on hardware as well. So you do see times where the emulator, like you'll see everything update. You might have like a tracking app, and you can see the pins moving along, the drivers moving along.
Yeah.
And then you run it on a real device, and like you see the map,
So,
but the pins missing. So
and the problem with the emulator and the simulator, but the problem with the emulator is that it's trying to create the hardware profiles through software. So there's still always going to be differences between the physical hardware and the software that represents the hardware.
Yeah, and usually you're running this on like a x86 type architecture device, right?
Yeah.
Like the emulator's running on that, and it's like in reality it's going to be deployed on like this one ARM64.
Yeah.
So this is one of the reasons why Aaron's upgrading his laptop to an M1 at some point.
Yeah.
I have to poke.
Definitely ARM will
No, I need
run
the
better.
ARM. Yeah.
Yep.
I've got the i7. I need the ARM now.
Yep. And then like okay, so like that's the beauty of Device Farm is these are physical devices. You can receive push notifications, like your app is actually running on the device, and so you know when there's actually a problem. So like I most people probably think that's like cool, but it's like to me like, man, like I get flashbacks of the war with running physical devices at my desk and having like 20 of them on charge, and then testing things in emulator or simulator, and then like testing one of the physical devices, and like, this should work. Why is it not working? Like the code's working in the emulator, and then like 2 hours disappear like while I troubleshoot.
Just a call out on that notice that you can see on the screen there. That's what I was saying before about the Google Store. So the Play Store is on the device, but to use it, you actually have to put in your account settings. So if you've got a Google developer account, then go in and use that one. And it is all uninstalled later, like after you've finished using the device, but you will have to put in your own account to actually use the Play Store.
Yep. And so this tool kind of like we went down a rabbit hole, but that's what we do in this show.
That's what we're here for.
Yep. So I basically took control of this Google Pixel. I have the hardware buttons on the phone available to me down the bottom, so I can go back home. I can go into my recent apps. It supports like gestures, so even though I'm using a mouse, I can simulate gestures. I can upload my APK or IPA file here, or I can choose, if I've had it in a run previously, I can choose to use that version that was in the run before. So what I did is I actually chose that version in the run, and you can see that the application that's going through the run in the background is here as well. And so I can open up the application. I'm like, yeah, cool. So it launches. That's number one. That's what I want to see. And then I can go, okay, so this user says that they have issues with the hamburger menu. And so I can click on the hamburger menu. Okay, so it looks like the main screen works, but that looks like a crash whenever I press the hamburger menu at the top.
Yeah.
And I can see that happen. And I'm like, oh, okay, great. Let me mark that down and put this into the backlog to investigate why this isn't working.
So the user was telling the truth in this instance.
Yeah, that's right. And so what I can do is I'll stop the session, and what that's going to do is I'll get the recording of what just happened, but I'm also going to get all the device logs as well, so I can pour through. Yeah, go, Aaron.
I was just going to say on this testing, right? That is actively recording everything that you're doing for the video. It's got the logs and everything. There is a maximum timeout, right? So if you you cannot exceed 150 minutes. So it will stop automatically after 150 minutes or at 150 minutes.
Yeah, that's right. So same things as the actual runs themselves. So the session's wrapping up. I'll go back to it. And what I might do is I might have a look at my run that I did. So run 1. So failed. So it looks like 3 tests failed. So that's not great. But I had 12 tests pass. And so I can go, okay, so let's have a look. So the past ones, I've got this video here. I can see the app was opened. So this person obviously got past this test. They got past the hamburger menu, which I just had crash on me before. They were able to log in a user and test logging in a user. So it looks like this test was successful. I can see all the passes here as well. I can go into the suites and I can have a look at them in particular if I wanted to in the particular stages. I can go look at the test spec, the logs of like what happened on the device. I can have a look at the performance of the device as well if I've enabled that as well, like memory usage, if I have a memory leak, or for whatever reason, like my app's having like high CPU usage when I open something that like like does something bizarre, and so I can cross-reference the performance timings with the video as well to see where that issue occurred. But then I've got access to like all the logging as well. So I've got like artifacts, I've got logcat files, tc dump logs. I've got all the logs here to go through and work out, like why my application crashed. This one was successful though. But if we go into the failed device, I'd be able to see. It looks like there was a case that I didn't account for where there was a wrong user entered and I didn't get a button pop up or something like that, right? Like whatever it is, and then I can go through and I can look at like the why that happened and why that wasn't expected.
Can you find quickly in the logs where that problem was? Just to show us how you would go ahead and debug something like that.
I could, although it's going to download some files locally. Let's see if we can tell in the logs here. So let's look at the time. So there's a socket problem. There's a warning. So these things are usually fairly noisy. So I'm like, okay, well, I can download like those specifically on my desktop, but I'm probably going to have a look at like the customer artifacts. I might open that up if I have time, and we can dive into that in a second. I'll unzip it as well. Actually, wait, no, this actually has a HTML. Here we go. I'll just open the HTML version and drag that in the window, and that way I don't have to re-screen share. So here we go. So we've got like failed one method. It failed that does this login page work. So it failed the actual test rather than a crash at any other time in the build process. And so I can see if I look at here, like no such element, cannot locate the element, looking for password text input by the ID password field. So it looks like an element was missing on this device for whatever particular reason. So that could be a problem with the test itself, or it could be a problem with the device exposing that to me successfully or not. Generally, these tests would be like, I was expecting to get a pop-up saying incorrect password or something, and I never got shown that in the UI. And so it couldn't find that element in the UI. So this test looks like it was actually missing the input itself. Going back, let's have a look at the device that I ran with remote access. So we saw that crash when we opened up the hamburger menu. So I could access the video there. I've got the logcat files, TC dumps. I've got all this stuff available to me. I can download the logs and I can have a look and find out what was the problem exactly as well with this. So that's pretty much like Device Farm. I did want to kind of like reshare my screen for like 2 minutes and just show you like a little extra. The one thing is Device Farm does work for desktop browser testing as well. So so it is handy if you've got web applications. It's not just limited to mobile applications. But if I close down what I've got here, and what I might do is I might try share my full screen, and we're going to have Hall of Mirrors for a second. So apologies. So look away very quickly. There we go. The Hall of Mirrors effect should have finished. So this is Appium Studio itself. If I go here, so like we saw that the tests could be done with a number of like platforms. Like you can use the native iOS or Android testing. Appium's really good because Appium's open source and it's compatible with a lot of other test frameworks for mobile devices as well. So what I do is, if I wanted to create a new test to run myself, I would add a Android or an iOS device. So I'd click on one of those buttons. Now it hasn't found one because I don't have a physical device with me at the moment. But if I was an app developer writing tests to perform to run on physical devices, I could actually use the iOS simulator or the Android emulator. And so if I go into JetBrains and I go into Android Studio, so if I open that up, I could actually launch an emulator, and I can actually record what I want to do in terms of like testing a login field or whatever it is, or testing a particular part of my app. I can write that as a test. I can save that test. I can bundle in a zip file with the Appium settings, and I can then run this across physical devices that aren't connected to my local PC, right, using AWS Device Farm. So I will launch my Pixel 4. So here we go. So this is just using the Android emulator. So I can see this is running locally on my machine. Now, if I go back to add an Android device, why does it come up with Melbourne News? That's great. It then finds this phone because it's running. If I did the same with iOS Simulator, like I went into Xcode, like I think we've got a little bit of time, so I'll quickly show you. There's Xcode. Surely it takes a little bit to load. Come on.
Yeah, these simulators, or the emulators always take a long time to load. They always use a lot of disk space as well.
Well, it's just Xcode's like 30 gigs just by default, right? Like, so just opening the IDE takes a while. Okay, here we go. And then I go developer tools, I go into simulator. Just waiting for it. Hopefully I see a simulator launch. Here we go. So I've got this iPhone 13 Pro device as well, so that can boot up. But once these devices are actually launched and on your these emulators or simulators are launched on your local machines, you'd be able to see each of them. So within Appium to start doing a test. So anyways, I'll use the Android one because the iOS one's still warming up here.
Is your personal preference to use Appium? Is this what you're seeing a lot of your customers go towards, Matt?
Yeah, and Appium's open source. Appium Studio's free, but it's built by a third party, but it's more visual than writing the test cases directly via code. Like it still produces the code, but you can actually like click through on things. It's got a nice UI. There's like a million frameworks in the space, but generally like a lot of them, a lot of the tests can be adopted for using an Appium. So when customers go, oh, we're using this like framework to AWS support, like do you have support for that? Generally what we'll do is we'll get support for that framework through adapting the the tests to be Appium compatible that the customer's written. And so AWS support actually helps with that process. But like you can see that I've got a series of applications. So if I had another application, I could import that application on the Android device that I booted up here. I can install a couple of like test apps as well. I could say, as before the test run, make sure this app is installed. And I can install the application on the device. So you'll see the simulator, so the emulator for Android change in a second. I always took a while to warm up before, just now. So anyways, like installing applications happening on the Android device.
You're working that ARM chip pretty hard, I think.
Well, this is my work PC, so this is actually a Intel.
Okay, well that's why.
Too many emulators on the one device.
Yeah, see? I might actually kill the simulator.
Yeah, system's not responding. You need to get an ARM. You need to get an M1.
I do. Here we go. It looks like I'm good now. But you can see like iOS and Android development is pretty intensive. Just running one emulator or simulator. I used to actually I used to upgrade like my RAM to as much as my work would let me. At the moment, I've got 16, which usually is good headway, but these days not so much anymore. Especially if you run like 4 or 5 emulators. So, anyways, I've installed the sample app that Appium Studio comes with. You can see there's a username and password box here. So if I wanted to actually write my first test, I would start recording. And it's just preparing. So I'll give it a little bit of time. Here we go. And so it opens up like a mirror image, right? So launches the app. Here we go. And then what I can do is I can click on the test, the username field, and I'll just enter like test user. And you can see it's like, it's doing it across, it's just a window into the emulator. It's both exactly the same device. And then I'll just go test password. And then I can hit login. And I see invalid username or password. Like this is actually what I want to see because it's validated that this user isn't real. This user isn't sitting within my auth system like Cognito. And so I actually think that this is a successful test, right? Because this is what we want to replicate and what we want to see for users that don't exist in our system. So I press the close button on that, make sure that works as well. And I'd say that this is behaving exactly as I expect. So what I'd do is I'd go back to the record button and I would stop the record. Now, what this has done is this has generated a bunch of code for me. So it's actually written Java code, basically like going through and doing the exact same series of steps that I just did beforehand. And I can run through this again on my app just by hitting the play button. So I could open up another emulator and I could do this exact same test across another device. And so if I hit play, you can see it just replicated the exact same steps in the app as what I just did beforehand as well. So I can go, okay, that's excellent. I'll terminate the test. And what I can do is I can save this test if I wanted to. Non-existent user. And if I wanted to, I could like have the Python version of this code. I could have a different Appium client used as well. So I can kind of like get different code samples for all of this. But what I'd do is I'd export each of these scripts, I'd zip it up into a zip file, I would have the Appium settings included in all of that, and then I'd be able to basically take all this stuff, take my APK file as well, my application itself, and then run all of this on physical devices in Device Farm. So I know we're right on time, well we're 5 minutes over actually. What I might do is I will stop my screen share, and if people want to kind of like test this out themselves in their spare time, this is the link for, like, if you followed my recording, you'd be able to play with Appium and basically like create a zip file to test your own applications with using Appium on Device Farm. So this is a good tutorial to kind of get started.
I think what you showed there, Matt, is, you know, there still are a lot of testers out there that are still manual testers, right? There is a demand for manual testers. They still need to be there. Making the leap between manual and automation can be difficult for somebody to go and say, all right, I'm using SpecFlow now. I'm going to write all these Cucumber-based tests or whatever framework they're implementing. When you use something like Appium to start that process to say, I can just record and the recording will generate the code, like you almost get to the point where you don't have an excuse to say, I don't know how to automate. I don't know how to build in some automation to my process of what I'm doing with regards to testing. I think it's a really good way to get started. Once you start seeing the output of the code, obviously you can go and change that code if you need to do something really specific. You know, you could put randomized things that come up there or whatever that you need to put in there and alter the code. But I think it's a really good like bridge to people that are saying like, I want to start doing some automation testing. Like it's something that people should definitely look into as well.
Yeah, and so I hope that was kind of handy for everyone today. There's not much material on Device Farm, that's why I felt like it's worth kind of taking everyone through, but it's such a handy service, and it's like literally, if I had it like 10 years ago when I started mobile app development with Objective-C and like old school like Java or Android gingerbread type stuff, like this would have saved my life.
I'm actually surprised we haven't done it earlier, or even that there's not a lot of content out there. Maybe that might be enough for us to go and write a blog about it. But because this actually comes up a lot in customer engagements, like asking how do we test on devices, and where often, I know, Matt, you've done many of these customer engagements around just Device Farm itself. So it's there. It is widely used. It's just kind of not well advertised, I guess. So
yep.
we should do a bit more.
Yeah, exactly. I think when you're a company, you'll go to AWS to your SA or your TAM and you'll go, hey, like how do we do this? And then we'll come on and we'll do it. But like if you're doing your own startup or you just want to like play with this in your app developer and you want to learn this stuff, like there's not much material. Anyways, I hope everyone enjoyed. Appreciate everyone staying. I know we went 7 minutes over time. Join us next week. We should have a pretty cool episode lined up at exactly the same time. And also, don't forget to check out Summit as well. So Sydney Summit, if you are based in Australia or New Zealand, or you're awake Australia, New Zealand times, come join us in 2 weeks as well. We'll be on the night event. But the whole agenda is pretty fantastic if you want to learn about different aspects of AWS. Thanks everyone for watching, and hope you have a good rest of your weeks.
Thanks, Matt. Thanks, Aaron. Thanks, everybody.
Thanks.
Take care.
Thanks, everyone. Bye.
Bye.